Hi, in this video we're going to learn about solving exponential inequalities. At the end of the video, you are expected to be able to solve on your own exponential inequalities. Let's start with definition. An exponential inequality in one variable is an inequality that can be written in the following form. A times b raised to x plus k is less than 0, or less than or equal to 0, or greater than 0, or greater or equal to 0. For the following conditions, a cannot be equal to 0, b is greater than 0, and b cannot be equal to 1. If these rules or conditions will be violated, we will not have an exponential inequality. So how do you actually solve exponential inequality? You can use the same methods used in solving exponential equations to solve exponential inequalities. What are the steps? Well, step 1, write the equation that corresponds to inequality. Step 2, solve for x. Step 3, this is the additional steps for inequalities. You could actually plot the x value on a number line, or we graph your inequality in a real number line where you draw a line going to the left or going to the right. Test intervals means you can check which are the sets of the solutions. Is it on the left or on the right? And that's where the arrow goes if after substitution it makes the inequality true. Let's have the example. So solve your inequality, exponential inequality 4 raised to x plus 1 is greater than or equal to 64. How do you begin? Write the equation that corresponds to inequality. Actually, what you need to do is just simplify your bases. Like when you solve your exponential equations, you should have like bases. If it's unlike, you need to rewrite wherein they will have the same base, and you will have an exponent. Supposed to be, there should be perfect numbers, perfect square, perfect cube, and so on and so forth. So looking at your power table, actually 64 can have a base of 4. It's actually 4 raised to 3. So we just rewritten our 64 into 4 cube. That's how you need to write your inequality in a simplified form with like base. That's what your step 1 is trying to say. Of course, we are now ready to write your actual inequality. You have x plus 1 is greater than or equal to 3 because we can now cancel your base. Okay, and now obviously we are ready to solve for your x. How do you solve? Of course, you just have to take out 1 by subtraction. Subtract both sides by 1 and you have x is greater than or equal to 2. Remember, on your inequality rules, it still applies that in the event that you need to divide both sides by negative or multiply both sides by negative, your inequality symbol flips. We did not flip it because we just added or subtract. The flipping only occurs when you multiply or divide both sides by a negative number. And the special property of your inequality, you can now plot x values on a number line and test intervals. So you just draw a real number line, and then you can just have the value or the boundary 2, but since it's equal, we will have a shaded circle. And now, since it says here x is greater than or equal to 2, the greater number are on the right side. So this is the location of your solutions. Greater than 2, including 2 because there's equal here. 2 and higher than 2 will make the inequality true. Let's have another example. Solve 3 raised to 4x is less than 9 raised to x plus 3. First step, you need to make sure you have the same base. Write the equation that corresponds to inequality. To come up with the inequality of your exponents, you need to make sure you have the same base. Here, 9 can have a base of 3. 3 squared is actually 9. And so we can just actually take out your 3, and we can now write your inequality. You have 4x is less than 2 times x plus 3, and then solve for x. You may start by performing your distributive property. This becomes 2x and then plus 6. And then subtract 2x both sides. And so you have 2x is less than 6. Almost done. Divide both sides by 2 and x is less than 3. And now we're ready to show in graphing form in real number line what are the solutions. You have to plot your x values on a number line, so you can just write 3 underneath in the middle. Since there is no equal, we will just use unshaded circle. And since it says here x is less than 3, wherever the pointy is, it's the smaller number. Wherever it opens, it's the bigger number. Since x is smaller than 3, smaller or lesser numbers are on the left, so these are the locations of the solutions, including -2, 1, 0, and negative numbers will make the inequality true. Okay? Let's have your third example. Solve 5 raised to 3 minus 2x is greater than 1 over 625. Your original equation, what you can do first is, remember, you can rewrite this one into a whole number base, and 625 can actually have a base of 5 raised to a number. It's actually 5 raised to 4. 5 times 5 times 5 times 5 is 625. If you have the power table, you can use that one. Remember to always refer where can we find 5 and 625 in the same row. We also flip this one because of the rule. If you have 1 over x, 1 over x is equal to x raised to a -1. Or, so you have here 625 raised to -1. 4 times -1 is going to be -4 with the new base 5, because the fourth root of 625 is 5. And so we will replace the whole value here by 5 raised to -4. And now we have the same base. And now we can write your inequality. You have 3 minus 2x is less than -4 after canceling your like base, and then you just solve. This is the property, just like your property of equality of exponential equations. That's the reason why we can do it by canceling your like base, and we can write your inequality of your exponents. And so we just solve for x. Take out your 3 first. Minus 3 and so you have -7. Divide, and then you divide both sides by -2. It's gonna become +7 over 2. If you could simplify it, it's fine. It should be 3 and 1/2 or 3.5, but 7 over 2 will do, and that's your final answer. Okay, x is less than 7 over 2. Sometimes you are not required for the real number line. Sometimes the multiple choice questions, instead of the inequality, it gives you choices with number lines, the graph of the solutions. So if we are going to graph it, it should be like this: 7/2 or 3.5. X is less than, unshaded circle. X is smaller, 7/2 is greater. The x are the smaller numbers we need, so the line goes to the left. and it's unshaded circle because there is no equal on your thing. Okay, pop quiz. I know you need time. Solve 3 raised to 4 minus 3x is greater than 1 over 243. Give it a try. Take your time. Try to learn. It's good for you. It's a brain exercise. And the correct answer is x is less than 3. Okay, there is no work here. You could keep on trying. What's important is that the answer is x is less than 3. But just use your power table. It will really help you. Let's have another set of example. Sometimes it can be written in words. 32 raised to x minus 1 is less than or equal to 4. Find the value of x. And then another problem you can try, 2 raised to 3x minus 4 is less than 4. There is no solution here. It's your challenge. And that's the end of the video. Remember, to solve your exponential inequality, you make sure you have the same base, and then you can now write your inequality after taking out or canceling your base. Solve for x, apply the same equation property, but remember, in case you need to divide both sides by negative or multiply both sides by negative, the inequality symbol flips. Okay, you may watch the video again if you need to. Thank you.